Hey, you know, 8 years ago, the Simpsons predicted the Super Bowl. They were showing it all about the Super Bowl. The score was supposed to be 19-14, and the score was.
The Simpsons? Did he say The Simpsons?
Yeah, the Simpsons.
Like the cartoon
Yeah,
Simpsons?
the cartoon The Simpsons. They were sitting down watching the Super Bowl, and it was Seahawks versus the Broncos, and the score was 19-14 at the end. It was like,
That's not it.
I don't know. I stopped watching it when it was.
When you graph these, I need to see that you have the right asymptotes. I need to see that you've made some attempt to give me some points. So this is, your book gives you like 6 steps, and again, I've kind of shortened it up a little bit. But you definitely need to know your asymptotes in your domain. So that's my step 1, what we've been doing the last few days. Factor the numerator and denominator, determine your asymptotes in your domain. That would also include holes in your graph. The book says then you should find your x and y intercepts of the graph. The only reason they say that is because that's supposed to be easy points to find. Your x-intercepts are just when you set it equal to 0 and solve it. And your y-intercept is when you plug in 0 for x. So that's supposed to be like some points that you don't have to work that hard for. If you don't find the intercepts and you still have a graph that has points on it and it's a right graph, you're still going to get credit for that. But I'm going to go through these steps just so you can see it. And then you want to actually put those on your graph. Graph your asymptotes, graph your intercepts, and then make sure you have at least checked where those are. What's really great about rational functions is the asymptotes help you know what kind of shape they're going to be. If there's an oblique asymptote, those graphs are a little bit weirder, so we'll have to maybe look at one of those. I will tell you that there's 2 of these on your unit test that you have to graph, so I tried to pick questions that are similar to the 2 that are on your unit test. There's a whole bunch of different types of these, but we definitely want to make sure that we can graph these, okay? And this, we only have 2 examples, and the next 2 things are just numbers, like just problems, so this is the worst of it to write out. It's definitely the worst.
So I found out my schedule for the rest of the week.
Yeah.
I have tomorrow off, and I work last week.
They're gonna get snowed in.
I'm hoping.
Tomorrow night's the best. That's the best night to have off because that's when it's gonna snow. So then Wednesday there'll be so much snow you can't go in.
I'm hoping that the week, like, our roads go under red, because if they do, we have to shut the store down. They should try to tell me that we didn't last time, and then I'm doing wrong, but I like to tell this place what they're doing wrong.
It's good.
A lot. You got 2 going on. Living.
She's awake.
Well, I've already drank 1 by the accident.
I'm gonna double page this for those people that are still writing, so we can get on to this. All right, so I believe in your book it says graph using the 1,200 steps that we tell you to use. It says using steps 1 through 8. So we're going to graph r of x equals 3 over x squared minus 4. So step 1, let's figure out what our asymptotes, maybe, or if you know your asymptotes, you know your domain. Do we need to factor the top of this? No, it's just 3. But we could factor the bottom of this into x minus 2 and x plus 2.
Why do you make the things on the lessons so easy? They're like double mercury is like worse. Yeah.
They're not always like that, but the last one I gave you to them. It's not always true. We do hard ones on here too. But you only have 3 problems on your homework tonight.
Oh, yeah.
That's 24 problems.
You're not doing all these steps. So I could say x equals 2 and x equals negative 2 are vertical asymptotes. You could also say the domain is everything but 2 and negative 2, but I feel like that's like saying the same thing. So I don't know. I'm not going to say all that. What about my horizontal asymptote? Is there a horizontal asymptote? The numerator is less than the denominator, which means it's y equals 0. You have to know those things, right? There's no work to show on horizontal asymptotes. You have to know those rules. The numerator is less than the denominator, it's 0. If they're equal, you take the leading coefficients. If it's greater than the denominator, then you check for an oblique. So you have to know those. We could go ahead and find our intercepts just because I want to show you this, but then we'll see if you like this or not. If I want to find my x-intercepts, basically you make y equal to 0. So if I set this equal to 0, I would get 0 equals 3 over x squared minus 4. Notice over here, I said to find your x-intercepts, you just set the numerator equal to 0. And I said that because it's always true. If I have something on the bottom here, do you agree that if it's 0 over here, every time you could multiply that over, and it cancels out the bottom, and this side's just 0? So if you have a fraction equal to 0, you can kind of just forget about the bottom when you're solving it, and you would just be left with 0 equals 3. Does 0 equal 3? Which means, what are my x-intercepts? No, it means there's no x-intercept. That's not true. No x-intercepts. We probably could have figured that out if my horizontal asymptote is the x-axis. Can it ever cross the x-axis? Well, I kind of it could sometimes, but it makes sense that there's not an x-intercept. Y-intercept is if you plug in 0 for x. I'm going to make an xy chart for that. So if I plug in 0 for x, why do they tell you to do that? Because usually you can do it in your head. If you plug in 0 for x, what are you going to be left with? Yeah, 3 over negative 4, or negative 3/4. So they say that because it's supposed to be easy to find. That's really what they want you to do, and now we just have to make the graph. Remember that when we graph asymptotes, we use dotted lines just to kind of help us show that our graph's never going to touch that. Let's see if I can make a nice graph here for you. Do you have any room left on your paper? Yeah. Okay, I forgot I didn't print these out for you, so that's good. If I printed it, you would all complain you didn't have room. See, that's why I didn't print them. Okay, I really was going to print them.
So which one was it?
The line was too long, and I decided it wasn't worth me going back for it because you would be okay. Because if it was bad notes, like if it would have taken too long, then I would have printed it. So what am I going to do? On my asymptotes, at x equals 2 and at x equals negative 2, I'm going to put a dotted line to show that I have two vertical asymptotes. And at y equals 0, I'm going to put a horizontal line. And the only point that I know right now is at 0, it's at negative 3/4, which is, almost negative 1. I could put a dot right there. The bad part about rational functions is I don't really have a shortcut for you, except for you have to pick some points to see what's happening. The outside edges will always be those L shapes, so you should only have to pick one point on either side of those asymptotes. But the inside could be a couple different things. And in pre-calculus, I always say, usually the inside is one of two things. It's either a parabola, or it's like a cubic-shaped graph, like the S-shaped graph. You have to pick points to figure out what's happening there. And so this is where you just want to use your calculator, try to be as efficient as possible, but you're going to have to pick some points here. Like, if I pick 1, I want to see what's happening. Like, is this going to go up? And then I'm still going to have to pick negative 1 to see, does this side go up or does it go down to make like an S shape? The good news is this one's not so bad, right? If I plug 1 in here, I would get 3 over 1 minus 4, or 3 over negative 3, which is negative 1. Which means that it's like right here. I'm going to pick negative 1 also to see what's happening, because I feel like that should tell me what's happening. Am I going to get the same thing? Yeah. Because it's squared. Which means if I know it's either going to be like a parabola or an S shape, do those 3 points tell me what I have here? Yeah, it looks to me like a parabola going down. The nice thing is, if I know that, I can use the asymptotes to help me know that it's just going to kind of go out and get close to those asymptotes. But I don't really have a shortcut for you here. You just got to pick some points. You also need to pick some points on the outside here. So I would pick 3. I usually pick like points right beside my asymptotes. And if you're going to get fractions, decimals, whatever you work with here, if you plug 3 in here, you're going to get 3 over 9 minus 4, or that's going to be 3/5. I'm not really looking that you graph 3/5, like, that looks like more like 1/2 than 3/5. I'm looking that you graph less than 1, right? 3/5 is less than 1. So at 3, it's less than 1. Do I need to pick any more points over there? Because I know it has a vertical asymptote, so this side's going to have to go up. And I know that it has a horizontal asymptote, so that side's going to have to go down. The other side is going to have the exact same shape. It's either going to be over here or down here. Some people always assume that they alternate, but they don't always alternate. So I say at least like pick another point, or at least plug it in your head and see whether it's going to be positive or negative. And I think because this is a square, if I pick -3, am I going to get positive 3/5 again? Because when I plug in -3, isn't it still going to be 9 minus 4? So I'm going to get that same little shape over here. And that's a pretty decent, well, mine's not that greatly drawn. But if I was doing it by hand on my paper, that's a pretty decent graph for not having to pick too many points and using my asymptotes. How do you feel about that? Memories of doing this? You did this in Algebra 2. We did it in pre-cal. Let's do another one. Yes. It wasn't really a question. Oh, that's not what I wanted to do. How do I get back out of here? Oh my gosh, I don't even know what I'm doing now. Okay. I want single page display. What's weird about this one? Part of it's in a fraction, part of it's not a fraction, right? If you see something like this, you need to make it all one fraction first so that we can use our rules. Because we can't use our rules about asymptotes if we don't have that all one fraction. So, can I make that all one fraction? What would my common denominator be? And it's not going to be anything harder than this as a common denominator, but I just want you to see that we need to multiply this side by x over x. So I would get on the top x cubed. This one I don't have to multiply anything by because it's already has an x. So x cubed plus 1 all over x is the same as if you broke it apart, because x cubed over x is x squared, and then that would leave you the 1 over x. You with me on that? What is my, oh, this is a weird problem. What is my vertical asymptote? Right, so that can equal 0. What about horizontal asymptote? There isn't a horizontal asymptote because the numerator is bigger than the denominator. What about oblique asymptote? It's not that either because that's 2 bigger than the bottom. Which means all I have out of this is that there's a vertical asymptote at 0. What about some intercepts? What if I set the top of this equal to 0? X cubed plus 1 equals 0. Can we solve that? I would get x cubed equals -1. Right? Yeah. Take the cube root of both sides. You can't take the square root of a negative number, but you can take an odd root. It's just -1. So let's see some points that we have. That means when x is -1, y is 0. That's what we just discovered. What about if I plug in 0 for x? That would be my y-intercept. Oh yeah, we should know this already. Can I plug in 0 for x? No, it's my asymptote. It's undefined. Let's graph this and see what happens. This seems kind of terrible. Asymptote right here. At -1, I have a point like this. I don't know what's going to happen here because I don't have a horizontal asymptote to make an L shape, so I might have to pick a few other points here. So let's pick -2 and see what happens. You're going to get -8 plus 1, which is -7 on top over -2. Well, I think that's 3.5. You with me on that or not with me on that? What? The stuff we're doing in here? No, we just do chapter 5 and 6, I think is about all we have left. We're in 5. Rational stuff. I don't know. If we plug in -3, watch what happens here. We're going to get -26 over -3, which is like, not that bad, but it's like 8 2/3. Agree or disagree? The more negatives I keep picking, the bigger these numbers are going to just keep getting. Does that make sense to you? And so it looks to me like this is just going to keep going up. We maybe want to see what's happening this way. So just to humor myself here, I'm going to plug in -1/2. And I'm going to use my handy dandy calculator here, which I hope you could use. -1/2 cubed plus 1 divided by -1/2. It's not a whole, it's just a weird little thing here. You get -1.75. So you get like something like this. And it kind of just, this side goes up, and this side just kind of keeps going down and getting closer and closer to it. Because there's no horizontal asymptote, like, just, it's weird. And watch what happens on the other side. It's crazy weird. Can I just tell you the points and you'll believe me? Okay. I love how quickly you guys just say that. If you plug in 1, you get 2. If you plug in 2, you get 4.5. If you plug in 4, you get 16. So it's going up pretty quick also. If you plug in 1/2, you get 2.25. So yeah, it kind of just comes down like this, and this side just comes down also. That's a weird graph. No big fan of that. No, because they keep getting closer and closer. A hole in the graph would be if this one started and like it stopped at 0. Like it's not a hole in the graph because nothing canceled out the top. Yeah, but this is like separate. Like this is like, you can't look at it and say, well, that's a quadratic and that's a rational. What happens when I add them together? That doesn't necessarily mean it's going to be anything. Like it's a weird graph. I don't. Talking about I pick easy ones for the notes. This is not easy.
Like the absolute value of the
I don't know, dear.
absolute value, right?
Is V shape.
Yeah.
Yes.
I'm always like x cubed or something.
No. I don't know. I don't know what you're saying. 12 is just like the first one that we did, where it's just a number on top, so that's really nice. 17, almost like the first one we did, except for there's an x squared on top, which means you're going to have a different asymptote for your horizontal. And then 39 is just like the one that we just did, only I think easier than the one we just did. I don't think it's as crazy. And so 39 might be the one that we look at. But you should be able to do 12 and 17. I'm telling you 100% that you have 2 of these on your unit test. that matters for the dual credit stuff. So make sure you try these. We didn't have a homework quiz today. I'm pretty sure we're not going to have a 2-hour delay tomorrow. So you can definitely expect a homework quiz tomorrow. Okay? Okay, maybe
Why
you...
do you even have it start delayed?
Because
The roads were ice.
a lot of the back roads were very icy.
Yeah,
Miss Hodge Road, apparently she like has a big hill on her road, and like she couldn't even go that way this morning because there were 3 cars. Like her husband called her and said, "Don't go this way. There are 3 cars." Like
I went later on